Right, today we are going to discuss our sixth paper. In this paper, we will discuss two past paper structured questions related to Vernier theory. Right, let's see the question. Right, today let's discuss about the 2002 past paper question, 2002 structured question. Right, I will share the question. Figure shows a part of the main scale and vernier scale of a certain vernier caliper when their respective 0 marks coincide. Note that the figure is enlarged. ඔයාලට කියලා තියෙනවා figure එක enlarge කියලා, right? You remember we have discussed question like this in our class, right? In this question, only a diagram is given. Therefore, you have to obtain all the points. You have to find all the points by using this diagram, right? Right, Pude. According to the diagram, you can observe that the main scale is calibrated in millimeters. There are 90 millimeter division coincide with the vernier scale, 19 millimeter division coincide with the vernier scale, and in the vernier scale, there are 20 vernier divisions, right? Now you can draw a simple diagram to identify the least count of the scale, right? Let's see the diagram. You can represent first, second, third main scale division and vernier scale division in a diagram to identify length of main scale division, length of vernier scale division, and also the least count, right? This one is the vernier scale. Here, 19 1 millimeter divisions are used to construct vernier scale, and in the vernier scale, this length divide into 20 vernier divisions. Then put a 19 millimeter division divide into 20 vernier division. That is, the length of vernier division should be less than the length of main scale division. millimeter 19 Therefore, length of vernier division should be less than the length of main scale division. Now you can find length of vernier scale division, right? Length of vernier scale division is equal to 1 millimeter into 19 divisions divided into 20. Then you can obtain the answer 0.95 millimeter. The length of vernier division is 0.95 millimeter. Now you can find the least count of the scale. Least count is the first gap, no? When these two divisions, these 0 divisions, these two 0 divisions coincide, no? Then you can find the gap between the main scale division and vernier scale division. This first gap is the least count. You can obtain 1 millimeter minus 0.95 millimeter. Then the answer is 0.05 millimeter. That is, the least count of the scale is 0.05 millimeter. Then you can find the second gap. Second gap should be 0.05 millimeter into 2, least count into 2. Third gap, 0.05 millimeter into 3. Now you have an idea about the vernier scale, right? Let's see the questions. Pude, read the first question. What is the length of vernier division in millimeters? Length of vernier division is 0.95 millimeter. So, determine the least count of the instrument. Least count is the gap between vernier division and main scale division. This first gap, right? It is equal to 0.05 millimeter. Then read the next question. According to the above figure, what is the least distance in millimeters of the vernier scale that has to move in order to make a vernier scale mark coincide once again with a main scale mark, right? Now you have to coincide another vernier division with the main scale, coincide another vernier division and main scale division, right? Put now you imagine, now you can shift this vernier scale towards the right side. Put if you shift this scale a distance 0.05 millimeter towards the right side, what will happen? These two divisions will coincide, no? Right, to coincide these two divisions, second millimeter division and second vernier division, you have to shift this scale towards the right side a distance 0.05 millimeter into 2. That is, if you shift this scale towards the right side a distance 0.05 millimeter, then you can coincide this first vernier division and first millimeter division. That is, this one is the least distance. You have, if you move the scale towards the right side a distance 0.05 millimeter, then you can coincide first vernier division and first millimeter division, right? Therefore, the answer is 0.05 millimeter. Got it? Right, Pute. Let's see the next question. Right, Pute. In the B part, they have given a solid cylindrical object. There is a cavity in the object, right? Now you have to take this measurement. This external height, external diameter, internal diameter of this cavity and depth of this cavity. Right, Pute. To take this external height, you can use external jaws of the vernier caliper. You can place the object between the external jaws. Got it? You can place the object between the external jaws of the caliper, right? And also, to take this external diameter, again you can place the object between the external jaws of the caliper, right? And to take this internal diameter, you can use internal jaws of the caliper, right? You can use internal jaws of the caliper to take this internal diameter. And to take this depth of this cavity, you can use depth gauge or depth bar, right? To take D1 is the external diameter, external jaws. To take H1 is the external height of the object. You can use external jaws. To take D2 is the internal diameter. You can use internal jaws. To take H2, you can use depth bar, right, or depth gauge, right? Right, Pute. Read the next part. Write down an expression for the volume V of the metal in terms of D1, H1, D2 and H2. Right. Balamude, lamai. Here, volume of this inner cavity must be subtracted, must be deducted from the volume of the whole cylinder, right? You can assume that the radius of this inner cylinder is simple r, podi r, right? Radius of this whole cylinder, capital R, loku R, right? Then you can write expression for volume of the whole cylinder and volume of the cylindrical shaped cavity, right? So the volume of the whole cylinder is pi capital R squared H1. No? Then volume of the cavity, pi simple R cross-sectional area into height. No? Then you have to subtract, then you have to deduct this volume of cavity from the total volume of the cylinder, whole cylinder, right? Then you can substitute capital R should be equal D1 over 2 diameter divided by 2. No? H1 minus phi simple R is equal to D2 over 2. R squared into H2. Then you can factorize. Ne? Phi D1 squared over 4. H1 metana phi D2 squared over 4. Metana 4. Oh. H2 then these are common factors. No? 5 over 4. May factorize karanna. D1 squared H1 minus D2 squared H2. This one is the answer. This one is the expression for the total volume of this metal piece, right? In this question, you have to find the whole cylinder, volume of the whole cylinder. Then you have to find the volume of the cavity. Then you have to deduct volume of cavity from the total volume, right, Pute? Right, Pute. Let's see the D part. In this part, they have given the position of main scale and vernier scale respect to D2 measurement, right? D2 is the internal diameter, right? Then you have to read the reading. Pute, according to the diagram, you can observe that 13th vernier division. This 13th vernier division coincide with this one is 22 centimeter mean 20 millimeter, no? 29th millimeter division. This 13th vernier division coincide with the 29th millimeter division, right? Now you can get the reading, right? What is the reading? Reading is the main scale reading 15 millimeter, 16 millimeter. This one is the main scale reading. Then you have to find this unknown length. It is equal to least count. The first gap is least count 0.05 into 2 into 3 into 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 0.05 millimeter into 13. The answer is 16.65 millimeter. This one is the answer. Right, Pute? Then, read the next question, second part. What is the fractional error? Now we have to find the fractional error, right? Fractional error is the maximum error over measurement. For a given scale, we assume that maximum error is equal to the least count. Then the least count of this scale is 0.05 millimeter. Measurement is 16.65 millimeter. This one is the fractional error. Right? Hari lamai. දැන් ඔයාලට තේරෙනවා this question is a easy question, right? කොබලන ළමයි මේකේ උත්තර ඔක්කොම හරියයි. ඒ කියන්නේ දැන් මේක ඔයාලගේ exam එකේ පුතේ 100න් ලකුණු 5ක් හම්බෙන question එකක්. බලන්න මේ පහම ගතපු අය. Raise your hands. නියමයි. right. දැන් ඔයාලට හිතෙනවා ඉතින් එතකොට මේකේ ඇති දෙයක් නැහැ නේ මේ easy නේ මේ ලකුණු මේ පහ ගන්න එක nothing නේ කියලා. right? එතකොට දැන් එහෙනම් කරන්න ඕනේ මොකද්ද? මොරටු යන්න ඉන්නේ උන් ටට්ටක් ගාලා ගිහිල්ලා බෑග් එක පැක් කරගන්න මොරටුවට ඕන මේ දේවල් ටික දාගෙන කොළඹ මෙඩිකල් ෆැකල්ටි යන්න ඉන්න අය බෑග් එක හදාගන්න ක්ලාස් එක ඉවරයි. නෑ නෑ එහෙම නෑ හොඳද? right. එහෙම වෙන්නේ නෑ ළමයි. right? One day when you face your exam, you have to remember, you have to revise more than 40 practicals. right? පුතේ මේ වගේ practicals 40ක් අපිට කතා කරන්න තියෙනවා. 40කට වැඩිය කතා කරන්න තියෙනවා. right? They will ask 4 questions out of more than 40 practicals. එතකොට ළමයි questions 4ක් අහන්නේ. දැන් මේ වගේ questions 4ක් අහන්නේ out of more than 40 practicals. එතකොට ළමයි මේක ගේමක් ලියන එක. තේරුණා නේද? තේරුණා නේද? ඒකයි මම ඔයාලට කියන්නේ ඔයාලා මේ කාලේ මේ දැන් ඔයාලා අද මේ practical එක ඔයාලා ලියනකොට ඔයාලට දැනුණු ෆීලින් එකක් තියෙනවනේ. ඒක ඊසි නේ. ඒ විදියටම ඒක මේන්ටේන් වෙන්න ඕන ළමයි. එක්සෑම් එකේදීත් ඔයාලා ඔය අද මේකට ආන්සර්ස් ලියපු විදියටම එක්සෑම් එකේදීත් ඔයාලා ආන්සර්ස් ලියන්න ඕන. තේරුණාද? එහෙම වෙන්න නම් ළමයි you have to build your memory. ඔයාලා ඔයාලගේ මතක හදා ගන්න ඕන. මේ theory points අමතක වෙන්නේ නැති විදියට මතකේ හදා ගන්න ඕන. තේරුණා නේද? ඒක ඔයාලගේ ගේම් එකක්. ඒක මට කරන්න බෑ. මට ටීච් කරන්න පුළුවන්. ආපහු මේ වගේ පේපර් ක්ලාස් එකක ඊළඟ ක්ලාස් එකට එන්න කලින් රිවයිස් කරන්න පුළුවන්. right? ඔය හැමදේම කරන්න පුළුවන්. ඔයාලගේ මතක හදන වැඩේ ඔයාලා කරගන්න ඕන. You have to make your memory. right? ඒක හොඳට මතක තියාගන්න. එතකොට මේ ෆීලින් එකෙන්ම exam question එක ලියන්න නම් මහන්සි වෙලා මේ points highlight කරලා මේ practical tutes ටික මේ ඔයාලට මේ හැම practical එකකටම දැන් next week I will give tute for the traveling microscope. right? ඒක design කරන ගමන් තියෙන. එතකොට ඒක දෙනවා. එතකොට ඒකත් මේ වගේ tute එකක්. right? You should remember you have to write 4 questions out of more than 40 practicals. හරිද? ඒක ලේසි වැඩක් නෙවෙයි ළමයි. එතකොට අමාරුයි. හරිද? අනිත් එක time එකත් එක්ක compete කරන්න වෙනවා. හරිද? time එකත් එක්ක ලොකු competition එකක් දෙන්න වෙනවා ඔක ලියනකොට. right? ඒක නිසා ලේසියට ගන්න එපා. හරිද? මේක විභාගයට යනකොට ඔයාලට ටිකක් අමාරු විදියට දැනෙයි. මොකද practicals එතකොට ඔයාලට 40ක් මතක තියාගෙන පුතේ ඒකෙන් තමයි මේක ලියන්න වෙන්නේ. ඒක නිසා මහන්සි වෙලා වැඩ කරන්න. right? Got it? right පුතේ. Let's see the next question. right පුතේ, let's see the next question. 2014 question. right පුතේ? Read the question. The following measuring instruments are given to determine the density of material of a small uniform cylinder, hollow cylinder, right? There are 2 measuring instruments, a vernier caliper to take length measurements, an electronic balance to measure mass, right Pute? Right. Read the first question. Simple A part. Before using a vernier caliper for taking measurements, What is the first step that you should take? පුතේ මොකක්ද අපි ඉස්සෙල්ලම කරන්න ඕනේ? You have to check whether there is a zero error. පුතේ, if there is a zero error, you have to add or deduct that error from your answer, right? ඔයාලා ඉස්සෙල්ලම zero error එකක් තියෙනවද කියලා බලන්න ඕනේ. You have to contact two external jaws. Just contact two external jaws. Then you have to observe main scale 0 and vernier scale 0, right? Then you can identify is there any zero error, right? The first step is check whether there is a zero error in the vernier caliper. Okay, let's see the next question. Write down an expression for density D of material of the container in terms of volume of the container, volume of the material V and mass capital M, right? B part, right? Is in the density equal mass over volume. In addition to measurements, outer diameter and inner diameter of the container, they have given a diagram, right? This one is the outer diameter D1. This one is the inner diameter D2. Then external height H1, internal height H2. These are the measurement you have to take to obtain the volume of the metal piece, right? In addition to two measurements, the outer diameter and inner diameter, these two, except these two measurements, state the other measurements that you would take using vernier caliper to determine volume of the material. First you have to need to find is there any zero error. The first measurement is zero error, right? The second one is you have to measure this external height of the object and depth of this cavity, right? You have to find zero error. First one is the zero error, then external height H1, this measurement you can obtain by using external jaws. Then you have to measure this height H2 by using depth gauge, height of the cavity, right? Or depth of the cavity, right? Let's see the next question. They have given some measurements, right? The figure 1 to 5 below shows all the relevant position of the main scale and vernier scale pertaining to set of measurements that has been taken in order to determine the volume of the material of the container. Relevant jaws, depth gauge, etc. that have been used to take each measurement are shown on the right side of the figure R. In this question, in the left side, they shown the position of the main scale and vernier scale. In the right side, they shown the relevant position of the internal jaws, external jaws, or depth gauge, right? Then you have to identify the measurements and reading, right? Let's see the question. This question, you need to find the least count of the scale before get the reading, right? Before read the reading, if given reading, you need to find the least count of the scale according to the given diagram. I will share the tute. Then according to the first diagram, you can identify that the main scale is calibrated in millimeters, right? According to the first diagram, you can identify that the main scale is calibrated in millimeters and 9 millimeter division coincide with the vernier scale. And there are 10 vernier divisions in the vernier scale, right? Then you can draw a simple diagram to identify the least count, right? Let me explain. First of all, you need to find the least count of the scale, no? Main scale is calibrated in millimeters. Then 9 millimeter divisions divide into 10 vernier division. Okay. When 9 millimeter division divided into 10 vernier divisions, the length of vernier division should be less than the length of main scale division, 1 millimeter. Now you know this length is 1 millimeter, main scale division length is 1 millimeter, and now you can find length of vernier division. Length of vernier division is equal to 1 millimeter divisions now we divide into 10, no? Then 0.9 millimeter. Now you know the length of vernier division. Length of main scale division is 1 millimeter. Then you can find the least count. Least count is the first gap, no? Least count is equal 1 millimeter difference between main scale division and length of main scale division and length of vernier division, no? 0.9 millimeter. That is least count of the scale is 0.1 millimeter. This first gap is 0.1 millimeter. The second gap is 0.2 millimeter. This one is 0.1 millimeter in 3, right? Now you have find the least count of the scale. Then you can find the given reading, right, Putala? Now you have find least count of the scale. Least count is 0.1 millimeter. Then you can obtain, then you can find the given readings, right, Pute? Let's see the first diagram. In the first diagram, you can identify, according to the first diagram, Pute, they have given these external jaws are just in contact. Contact. That is, you can identify zero error of the instrument by using the first diagram, right? Let's see the zero error. According to the position of main scale and vernier scale division, you can identify that second vernier division coincide with the second millimeter division. That is, the zero error is, the first measurement is zero error. Zero error. Reading is, what is the reading? 0.1 millimeter into, first gap is 0.1, second gap is 2. 0.02 millimeter. First reading is 0.2 millimeter. This one is the error. No? Now, the zero error is 0.2 millimeter. Read if the reason for the error is given. Read the question again. Reason is not given. Is, I told you, right? I told you if the reason is not given, you have assumed that the error will affect equally all the measurement taken by the measuring instrument, right? In this question, the reason for the error is not given. No? Therefore, you have to assume that this error will affect equally on every measurement taken by the measuring instrument. You have to deduct, that is, you have to deduct this error from every measurement you taken by the measuring instruments to obtain corrected reading. Right, Puti? Right, Lamai. Let's see the second diagram. In the second diagram, they have given that the second reading is taken by using external jaws. Right, Puti? You should remember, according to this object, there are two readings that can be obtained by using the external jaws, this external height and external diameter, right? Right. First, find the reading. Okay. Reading is, what is the reading? Reading is 2 centimeter mean 20 millimeter, no? The main scale reading is 20 millimeter plus. Then you have to find this unknown length by using the vernier scale. You can observe that the second vernier division coincide with the 22 millimeter division. Then the answer is first gap is 0.1, second gap is 0.2. 0.1 millimeter into 2. Then the answer is 20.2 millimeter. Right? Now you can write the second reading, 20.2 millimeter. Then the corrected value you have to deduct 0.2 millimeter from your answer. Then 20.0 millimeter. 20.0 millimeter. You should remember, Pute, you have to write this 0, right? Why? In this question, you check the measurement up to first decimal point. No? Now you know the second decimal point. The value of second decimal point is 0. You definitely know, no? Therefore, you have to mention 0, right? You have to mention the value of the first decimal point here, right, Pute? Then you have to mention the measurement, Pute. Before mention the measurement, you need to find the fifth measurement. Why? Fifth one is taken by using, the fifth measurement is taken by using
external jaws, right? There are two measurements that can be obtained by using the external jaws. This external diameter and this height. First read the fifth measurement, then you can identify the reading of fifth measurement, then you can compare the length. According to the diagram, you can identify that this height is greater, no? මෙයාට තියෙනවා ලොකු value එකක් නේ. Therefore, the greater measurement should be the height or external height. This one, පොඩි එක්කෙනා ඉන්නේ කාටද? For the external diameter. Right, Pude? Let's see the fifth diagram. Pude, according to the fifth diagram, you can observe that fifth reading is taken by using external jaws. The reading is the main scale reading 35 millimeter. 35 millimeter plus this unknown length is fourth vernier division coincide with 39th millimeter division. Then first gap, second gap, third gap, fourth gap. 0.1 millimeter into 4. Then the fifth reading is 35.4 millimeter. Now you know the fifth reading, right? Third, fourth, fifth one. 35.4. Then you can find the corrected value. You have to deduct 0.2 millimeter, no? Then 35.2 millimeter is the corrected value. Then you have to identify these two readings. Pute, according to the diagram, you can observe that this external height is greater than this diameter, external diameter. Therefore, this one, this one should be the external height. External height. This greater distance should be the external height, right? And this one should be the external diameter, right? Here you have to identify which one is the external diameter, which one is the external height, right, Pude? Then you can read the third and fourth measurement, right? Let's see the third measurement, Pude. Right, Pude, according to the third diagram, you can identify that the third measurement is taken by using internal jaws. That is, third measurement should be the internal diameter of the hole, right? Then you can, this one should be the internal diameter, right? Then you can obtain the reading. Okay, this one is the 15th millimeter division, no? This one is 16 millimeter. The main scale reading is 16 millimeter. And you can observe that this second vernier division coincide with the 18th millimeter division. That is, this one is the first gap, this one is the second gap, 0.1 millimeter into 2. Then 16.2 millimeter is the reading. Reading is 16.2 millimeter. Then you can obtain the corrected value. To obtain corrected value, you have to deduct 0.2 millimeter from your answer. 16.0 millimeter is the corrected value, internal diameter. Right, Pute, let's see the fourth diagram. According to the fourth diagram, the fourth measurement is taken by using the depth gauge. That is, the fourth measurement should be the depth of the cavity. It should be the depth, right? Then you can find the reading. You can observe that the main scale reading should be the 30 millimeter. Then you can observe that second vernier division coincide with the 32 millimeter division. 3 centimeter mean 30 millimeter. No? This 32 millimeter division coincide with the second vernier division, right? Then this unknown length is 0.1 millimeter into 2, right? Then the reading is 30.2 millimeter is the reading. Then you can obtain the corrected reading. Corrected reading should be, you have to deduct 0.2 millimeter, 30.0 millimeter. Right, lamai. Kobalanda me measurements okkoma hariyata gatapu aya. Right, Pude, this question is a good question, right? ඔයාලට තේරෙනවා ඇති 2002 ප්‍රශ්නෙට වඩා මේක පොඩ්ඩක් ස්ටෑන්ඩඩ් එක වැඩිනේ. Bit difficult, right? You have to find several readings. And you have to identify the reading, and you have to compare the two readings that taken by using the external jaws, right? According to the diagram, ne diga වැඩි කෙනාට height එක ගියා, දිග අඩු කෙනාට diameter එක ගියා. ඉතින් මේ වගේ point exam එකේදී ඔයාලට miss වෙන්න පුළුවන්. Got it? Right. ඒක නිසා මේ question එක හොඳ question එකක්, right? Compared to අපි compare කරනකොට 2002 ප්‍රශ්නෙත් එක්ක this question is a good question, right? Let's see the next part. Right, Pute, in this part, you can identify that they have given symbols for each measurement, and using these symbols, you have to derive an expression for the volume of the cylinder, right? Volume of the metal piece, right? First, you have to find the volume of the whole cylinder, then you have to find the volume of this cavity, then you have to deduct volume of cavity from the whole cylinder, volume of whole cylinder, right? Right. You can assume that the radius of the whole cylinder is capital R, external radius is capital R, internal radius is simple R, right? First, find the volume of the whole cylinder, phi capital R squared, height x4. Then you have to find volume of the cavity. Cavity is a cylindrical shape, no? Phi simple R squared x4, cross-sectional area into height x3. Then you have to deduct the value. Then you can substitute capital R as x1, external diameter over 2, no? x1 over 2 squared x4. Then phi, simple R is the internal radius. Internal radius is equal to internal diameter divided by 2 into x into square, sorry, internal diameter divided by 2 squared, right? Then height is x3. Then put a phi x1 squared x4 over 4, 2 to the power 2, no? Minus phi x 2 to the power 2 x3 මෙයාගේ squared එක 4 වෙනවා. Then you can factorize 5 over 4 common, x1 squared x4 minus x2 squared x3. This one is the answer. Right, Putay? First, find the volume of the whole cylinder, then volume of the cavity. Then you can deduct the volume of the cavity from the volume of whole cylinder. Then you can obtain this expression. Right, Putay? Right. Let's see the next part. Right, Putay, in the next part, you have to substitute this corrected value for these symbols, right? Then you can find the volume, right? You can take phi as 3. They have given, no? X1 is the external diameter. External diameter is 20 squared. X4 is the external height, 35.2, right? Minus, you can substitute the values in millimeters. Then you can find the volume in cubic millimeters, right? X2 pute, x2 is the internal diameter, 16 squared. X3 is the internal depth, 30. Then you can find the values. 3 over 4, මෙතන 400 වෙනවා. මෙතන 35.2 minus මෙතන 256, 16 squared 256 into 30. Then you can find the answer. The answer is 4,800 cubic millimeters. Answer is 4,800 cubic millimeters, right? You have to simplify this value, right? Then you have to convert this cubic millimeter into meter cube, right? ඔයාලට මේ මිලි අයින් කරන්න නේ තියෙන්නේ. ඔයාලා දන්නවා කොහොමද මේක කරන්න ඕන කියලා. Milli is 10 to the power minus 3 meter into 3, no? Then 4,800 into 10 to the power minus 9 cubic meters. පුතේ මෙතන decimal points 3ක් අයින් කරන්න පුළුවන්. 4.8 into 10 to the power minus 6 cubic meter is the volume of the metal piece, right? This one is the volume of the metal piece. Then they have given the mass of the object. Mass of the object is 9.6 gram. Again, you can convert this value into kilogram, right, Pute? 9.6 kilogram. When you substitute new prefix, you have to multiply both numerator and denominator by the same factor. Then you can substitute kilo symbol instead of 10 to the power 3, right? Then you can bring this term from denominator to numerator. 9.6 into 10 to the power minus 3 kilogram. Did you remember? We discussed these things, right, under unit conversion, right? When you substitute a new prefixes in front of given unit, you have to multiply both numerator and denominator by the same factor. Then you can substitute symbol for the 10 to the power 3. Then you can bring this term from denominator to numerator. Then the answer is 9.6 into 10 to the power minus 3 kilogram. Okay, then you have find the density. D equals m over v. No, mass they have given 9.6 into 10 to the power minus 3 kilogram. Volume is 4.8 into 10 to the power minus 6 meter cube. පුතේ මෙතන 1යි මෙතන 2යි. Then the answer is 2 into පුතේ මෙතන මෙයා උඩට යනකොට 10 to the power plus 6. Plus 6 into minus 3 plus 3 kilogram per meter cube. This one is the answer. Right. Then the density is 2000 kilogram per meter cube. Right ළමයි. කො බලන්න මේ ඔක්කොම හරියයි. පොඩ්ඩක් ඒක නම් ටිකක් අමාරුයි නේද ළමයි? question a bit difficult. ඔව් කලින්කට වඩා පොඩ්ඩක් අමාරුයි right. හැබැයි ඔයාලට තේරෙන්නේ නැති දැන් මොනවද exam එකේ අහන්නේ කියලා. තේරුණා නේද? එතකොට පුතාලා මේ theory points මේ අපි discuss කරපුවා ඔයාලගේ papers හරිද? ඔයාලගේ tudes මේවා හොඳට study කරන්න. You have to build your memory, right? මොකද you should remember they will ask 4 questions in your exam out of more than 40 questions, right? එතකොට මේවා දැන් ලේසි වුණාට එතකොට අර points ගාන වැඩි නිසා ඔයාලට අමතක වෙන්න පුළුවන්. ඒක නිසා දැන් ඉඳලා පිළිවෙලට පාඩම් කරන්න. Right පුතේ, next week we will discuss our next topic, traveling microscope, right? එහෙනම් අපි Saturday හම්බෙමු.